Good morning.
All right, thank you for all coming online today. Today we'll be looking at patterns and algebraic rules. I want to welcome everyone that's here today. Let us begin. So we're going to be looking at patterns and algebraic rules today. So what is algebraic thinking? Anyone wants to help me define what they would understand from algebraic thinking? Nobody? We have to call you out by names. All right, since it's early in the game, let us just discuss. So algebraic thinking has to do with several things. When we are predicting patterns, we're thinking an algebraic way. When we're visualizing information, describing change or justifying a rule, describing a rule, when we look at different representations of something or organizing information, we are thinking algebraically, okay? So let us look a little bit more into what this really is. A way of thinking about data and information that emphasizes consistent sameness, differences, repetition, and changes that lead to generalizability of structure or result. All of that is algebraic thinking, right? So, or warm-up activity. Let us look at that. All right. So we have building algebraic reasoning activity. So now I want you all to look at pattern 1, 2, and 3. So I see that we have someone from Tarrant, Kadeen Lewin. We have Karen Campbell, Orlando Thomas, Sean, all of those names that I just called. Try to remember. We're going to have a discussion. So we have pattern 1, pattern 2, pattern 3. Determine the number of circles that will be in pattern 40. Now, before we do the pattern 40, I want you to look at the patterns that you see and see how you can move from pattern 1 to pattern 2, pattern 1 to pattern 3, pattern 1 to pattern 2, then 3. So I want you to see the pattern as it is moving and tell me. I want you all to draw an image or tell me how you see the pattern at 1, and as it is moved to pattern 2, how do you see the changes, the differences, the sameness with these 3 patterns? You have a few 1 minute to come up with that. Feel free to raise your hand. You can draw the diagrams on a paper and just open it up in your screen. Right, so you can draw it on a paper and open your camera and share it, or you can definitely describe what you're seeing if you so desire. All right, is anyone ready to share how they would have moved from pattern 1 to pattern 2, how they have made the change, and from pattern 2 to pattern 3? What are you seeing that's similar? What are you seeing that's different? What is being added? However you want to describe what is happening. What about Kadeen? All right. Seem as if no one is going to provide any way in which they have viewed the pattern. So let us look at some possible ways in which we could decompose design seen here. So this is what Paul would have seen in the 3 designs. So pattern 1 he would see all the 5 circular circles. In pattern 2, so this would have been his base pattern, and then he would have seen one, it's really not a circle, it's a circular shape placed onto either side at the top, and then one onto the bottom of those 3. Then he would have seen his base figure or his base pattern, and then 2 for the third pattern, 2 on either side, and 2 also added to the end of that pattern. All right, so it's not, you don't have to see it that way. And if you didn't see it that way, it's quite understandable. Here's Karen's view. So Karen saw 2 main, so 2 was her base, 2 of those circular shapes, then 1 on either side of the top circular shape, then 1 on the to the end. So as you can see, you may see the first pattern differently. All right. So the second pattern for Karen, she would start with her 2 blue circular shapes, and that would be her base, and then 2 to the either side of the top circular shape, and then 2 to the bottom of the circular shape, and that would form her second pattern. So the third pattern, I can just imagine what the third pattern would look like. So 1, she would have seen 1 on all sides, and for 2, 2 on all sides. So I hope you're following. For the third design, she would have seen 3 to the top, to the left and the right, and a set of 3 circular shapes to the end, to the bottom of the pattern. Now here's another view. So this is how Adam saw when he looked at the design. So his base would have been the 3 circular shape in the middle, and then 1 green circular shape on either side at the top. So his base, so he changed the base for pattern 2. And it now started with 4, and he would put 2 at either sides, and the next base now becomes 5. 1, 2, 3, 4, 5, and he would put 3 on either side. So it depends on how you view the pattern, would help you to figure out what's next. So there's no set way, as long as your process of thinking is logical and consistent. It pulls through for every pattern in this sequence. So Mark saw two of those circular shapes as his base there, then 3, and he would have seen the 3 at the top differently. and then you'd have pattern 2, 3 at the base, and you'd have 5 at the top, 4 at the base for pattern 3, and then you'd have 7 at the top. So you can definitely view the pattern differently. I've been saying that. Now, as you look at the pattern, the original pattern, did you look at the pattern and figure out the base 2? Then use it to predict the 40th case. That is really what we want to look at. Did you relate the number of dots to the pattern number? So let us go back to the first one that we would, it doesn't matter, it's the same thing here. But let us look at this one. If we would have looked at this one where we had, I'm trying to take you back to our first image. Here we are. So we have the first pattern, you would have had how many dots? You'd have had 5 dots. That's pattern 1, 5 dots is there. Now, how could you use this to help explain what is happening for the second pattern? You could use your 5 dots, correct. You could use your 5 dots as your base, and then you'd see, for your pattern 2, you would still put back your 5 dots, and what would have happened? You'd have added 1 dot on each side. So let's look at what Paul did here. We're going to just focus on what Paul is doing. So Paul would have put 1 dot on each side of his original base, and that would have been for pattern 2. So there you go, 1 on either side. So how many dots does he have now? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8. So he started with 5, and now he has 8. Let's look at the third design. So remember, he started with 5. He placed 2 over there, 2 over there. So that's 5 and 4. That's 9, and 2 more at the base. So that's 9 and 2. That's what? 11. Can you establish a relationship among the 3 patterns or the 3 designs? So I can see that I would have added 3 to get pattern 2. Did I add 3 more to get pattern 3? Yes, ma'am. So I would have added, so I started with 5 and I added 3 to get pattern 2. By the time I reached pattern 3, I would have added 3 2 times. So I can therefore try to see if my generalization would take me for pattern 4 if I add another set of 3 on those 2 sets of 3s. So remember, now I have 5 for 1, 8 for 2, 11 for 3, and I would add 3 to that, which would give me 14 for pattern 4. All right, and we could definitely go on and build up on that, but let us continue. So we would have looked at all the ways. Stop. So here we are. So we would have looked at figuring out how we could relate the number of dots, which we can call D, to the pattern number. So D, number of dots, equals 3n plus 2. And I hope we could have worked that together, but I'm having very little conversation from my group here. All right, is anyone wants to ask a question at this time? Feel free to open your mic. All right, we're not going to spend any more time on that. For decomposing pattern task, let us look at a sample CSEC question here with sequence and patterns. A sequence is of figures is made from lines of unit lengths and dots. The lines form a series of octagons and squares. The dots are placed at the vertex. The first three figures in the sequence are shown below. So we have figure 1, we have figure 2, figure 3. What pattern are you seeing in the sequence here? What is happening? All right, so if you are looking at the first figure, you'd have realized, as it clearly says, it's an octagon, and you can count the sides, so let us use a little, if I can get a pointer in here or annotate here.
Miss
So
Lodge Benton,
yeah.
my hand is up.
Okay, sorry, someone please monitor the chat for me so I can, go ahead. Whomever hand.
I was going to morning everyone. I was going to miss that with each pattern a new octagon is added, and from those vertices lines are crafted.
Just repeat the last part. I heard that you said the octagons are added and
from the vertices lines are crafted outside of the octagon.
okay. So you see the figure 1 and the figure 2. You see you agree with what figure 3 looks like?
Repeat, miss.
Can you figure out what figure 4 will look like?
Yes, miss.
All right, so the shape that is in figure 1 is an octagon. The shapes that are in figure 2, what are they? Just for description.
What did you say?
Okay, so for figure 1, we have one octagon. In figure 2, if you were to describe it, what would you say? What are the shapes that you see?
2 octagons and 2 diamonds.
All right, awesome. So you see 2 octagons and 2 diamonds. What about figure 3?
3 octagons, 4 diamonds.
Excellent. So if I asked you to tell me what you think figure 4 would have in it, what would you say?
4 octagons, 6 diamonds. 4 octagons and 6 diamonds.
All right. Anyone disagrees or agree with him? You can raise your hand or put up a yes or something in the chat. You?
Yes.
You agree?
I disagree.
You disagree. What do you think the 4th shape should look like, or what the shapes?
What shapes? 4 octagons and 8 diamonds.
And 8 diamonds. All right. So we are so figure 3 has 3 octagons and 4 diamonds. And all right. And you think it should have 8 diamonds and 4 octagons for the next figure?
Yes.
All right. Anyone else has another look at this design? All right, so far we've been adding for the next figure, 1 octagon is added and 2 diamonds, and the octagon, the vertices in the middle of the 2 octagons are joined by lines, giving you that diamond in the middle. So let's look at this. So here, if we look at the first octagon, so I'm trying to find a pointer and I'm so not finding one. All right, that is different. All right, let's look at this pen. Let's see first. I do apologize, guys. Let me just close this out and get you back there. Sorry about that. And that session. All right, so let's go back to this. I do hope it did not go from the front, but pick up from where we were. Do apologize. I the fourth figure would have one more octagon, and you would have now been joining those two last octagon by a pair of diamonds. What is happening? All right, here we go. All right, guys, we would have been delayed a little. I do apologize. All right, so the next, so I agree with the first person would have been 4 octagons along with 3 pairs of diamonds. And that would have given us, so here we go, that would have given us this figure here. And we have to be going through all this again, and I listen, you know, technology sometimes get the best of us, but I would have gone way past the diagram now. Here we go. So here we are, and it is a little bit skewed, I guess, because of all that I've been doing with the presentation. So you would have had 4 octagons and 6 diamonds. That would have been figure 4. And that's pretty much what you would have just drawn on your paper with to show that you would have added 1 more octagon and joined them by the vertices. So a sequence in English, it still refers to a group of things arranged in some particular order. So CSEC does have questions that expect you to look at the patterns and derive the correct solution. A mathematical sequence is a set of numbers or geometric arrangement that makes a pattern, and it can be simple or it can be complicated. It can also be a finite sequence, and you can also have sequences that are infinite. All right, sequence, here's a simple sequence. We have 2, 4, 6, 8. The first term being 2, second term 4, third term 6, and the fourth term is 8. Can you tell me what the 5th term would be?
10.
10. So it means that, so this particular sequence is an infinite sequence because it can go on forever. And you can simply see the rule here is 2 being added each time for the next term. All right. So let us recap here. We look for a number pattern in a sequence, and we just stated a similar one to this, 2, 4, 6, 8, and we will realize the rule here is that we're adding 2. So the next sequence would have been 10, and we can keep on adding 2 for as many sequences or many sequence within the same pattern, the next term, not sequence, for as many terms within the sequence. And here's another 4, 8, 12, 16. Here we're not adding 2, but we're adding 4. And this is pretty much just recapping what you should know and you've been doing. So it's nothing difficult here. Okay, and then we can definitely look at what would be the 10th term if we were to look at this. So here we are. We are going to use the rule. We're going to use rules to determine the next pattern. So the first pattern is 1 square. The second pattern is 2 square. What's the third pattern? 3 squares. However, it's not just the number of squares that we're looking at. What would be the pattern, the arrangement of the squares for the fourth pattern? Who would want to take that on?
Miss, I'm drawing.
Okay, draw it and open up. If you can either describe or I can stop sharing and you open up your camera. And then while you're drawing the fourth pattern, someone else can draw the fifth if they. Now there's a number of sides that you can see here. So several things are happening with this pattern. The term 1 has 4 sides, term 2 has 8 sides, term 3 has 12, 4 has 16, and 5 has 20 sides.
Yes,
No.
can I answer the question?
Okay, go ahead. What question are you answering?
So the fourth figure would have the round square at the bottom right corner of figure 3, and that's how you get the four terms and the number 16 number of sides.
Okay, so for someone who is not quite sure what's happening, can you tell me what is happening from term 1, 2, 3, and know where you are at 4? Can you describe the pattern, the formation of the pattern? I'm not saying that you're wrong with what you said, I just want you to describe how you got there.
All right, so basically you add 1 square and they're going in like figure 2. The second square is in a diagonal form. It's laid out in a diagonal order, and then it's inverted at figure 3. So
Okay.
therefore, figure 4 square would be inverted again.
All right. So 4 would
So
you?
it's like a crest on a rock and a pattern.
It's like a what?
So it's like a up and down movement. Up and down movement.
I like that. Okay, so 1 is up, 2 goes down, 3 is up, down, up again. So 4 would be down again.
Yes, yes.
All right. And there you go. So 5 would be?
Up again.
Up again. Awesome. So once you can identify what's happening within the sequence, you can pretty much predict the next pattern. And that would definitely be you thinking algebraically. All right. So here we go to another way in which we can look at how we identify patterns and use it to see what comes next. The rule is that we add 4 to the previous term. And this would have been, if you look at the table here, you'd have looked at the number of sides. To get the number of sides, you are adding 4 to 4, which gives us 8, because we are adding a square, and a square has how many sides? Or we're adding, yes, this looks, a square has 4 sides, so we're adding 4. So 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20. So that is what we are here for, looking at the number of sides that we would get as the pattern increases. All right, now 4, 8, 12, 16, 20, they're all multiples of 4. So definitely we could multiply the term number by the common difference of 4, okay? So the first term, calling it 1, 1 times 4 is 4. Second term, 2 times 4 is 8, and we could definitely continue to find the number of sides by multiplying the term that we're looking at by 4. And here we put this in a formula just how we're just building how we look at a pattern question and figure out how we could write simple algebraic expressions to express what's happening. The number of sides equal 4 times n. N is the term number, and we can definitely use n is a common letter that is used to denote the term, and we would end up with 4n. All right. Some rules are not so straightforward as the ones that we just looked at now. Some rules have 2 things happening, 2 stages. So let us look at the pattern here. We have the first term, which is 3 tiles. We're going to call them tiles. The second term has how many? So we have 1,
5.
2, 5 tiles. Thank you. The third term has has 7. So how many would the fourth term have? Are you seeing what's happening here? What is happening for each successive term? All right, go ahead.
Yeah, I add 2, then I add 3, then I add 4. Like, yeah, count.
Okay, tell me about that 3 and the 4. So for term 1, how many would I have added? To get to term 2, I added how many? Huh?
2. 3 minutes.
I added 3 to get to term 2.
2.
I added 2.
Yeah, I
2
did
minutes,
3.
yes.
How many did I add to get to term 3 from 2 or from 1?
4.
4.
Okay, so if you're looking from term 1 to term 3, I would have added 4, right? And you can see it's what is it? Have I added 3 or 5 anywhere there?
No, miss.
No. All right. So we have to make sure we are paying attention to the pattern.
Right? So what do you think term 5 would look like?
Miss, it would be 11.
You'd add 8.
Miss add 8.
Add 8. All right. Did you get your 8 there?
Yes.
Yes, miss.
All right, great. All right, so now that we've looked at that, let us look at it differently now. So those are the terms. It is the same information now. We've represented it in a table, however. So we have figure 1, figure 2, 3, 4, and 5. Remember the number of tiles in figure 1 was 3 tiles. We added 2 to it, we got 5 tiles. We added 2 to that one, and we got 7 tiles. And we kept on adding 2. All right, so let us look. So our base pattern consisted of 3 tiles. And we added 2 to get the second term. We added 2 sets of 2s to get the third term. We added 3 sets of 2 to get the fourth term. And then we added 4 sets of 2 to get the fifth term. Can anyone help me come up with a pattern, with an expression that can describe what I've been doing as I added these 2? Do you see a relationship with the figure number and how many 2s we've been adding? I'm giving you a lot of information there, you know. All right, let me help you a little bit
This
more.
is Lodge Fenton. There is a raised hand from Gareth.
Go ahead, Gareth.
Okay, so Miss, in that sequence, the
Mm-hmm.
term number is equal to 3 plus the previous, like figure 1 is equal to 3, so figure
Mm-hmm.
2 equal to 3 plus one set of 2, so it would have been the previous term number sets of 2.
Oh, okay. Look at that.
There's also another sequence that could be used,
Mm-hmm.
because if you look at it another way as well, when you multiply the term number by 2 and then add 1, you still get the same number of tiles each time.
All right, so the term number, so if we, so what you're saying, 3 times 2, you said multiply the term number by 2
Yes, miss.
and add 1.
Yes, miss.
All right, so the term is 1 multiplied by 2 gives us 2 and add 1. All right, so n times 2 plus 1. Okay, so we're using the term number as n, and we're just seeing if that plays through. So let's try for 4. So the term number is 4 multiplied by 2 plus 1. And what's the answer for that? So 4 times 2 is 8 plus 1 is 9. Good job. So we could definitely multiply. So we could say 2n. All right, let's write the n multiplied by 2 for now. So what's your name again, Gareth?
Garrett, Paul.
Okay, Garrett. So Garrett is saying that there are 2 ways we can look at figuring out the next term. We can, he said first, he realizes that it is the previous term multiplied by the set of 2's. So for term 1, you have, how many sets of 2 you had? You have added to 3.
Repeat, miss.
How many sets of 2 are we adding to the 3? What is the previous? Yes, you said the previous term. So what would come before 1? Term what?
0.
Term 0. So we've added 0 sets of 2 for figure 1. So it would be 3 plus 0, which would give us the 3. For figure 2, we would have 3 plus how many sets of 2's? 1, right?
Yes, miss.
All right, great. So 3, 1 set, so it's 1 multiplied by 2 because it's 1 set of 2. So that would be 3 times 2 gives us, you said added, not, okay, 3 plus 2 would give us 5. Correct. All right, so now what if I wanted to write this down in terms of n, the nth term? Because what if they asked me to find the 15th or the 26th term, and I didn't want to write out from 1 to 6 to 26. How can I write an algebraic expression that could help me determine any term at all? The nth term. It doesn't matter what term they give me. All right, we're going to build on what Garrett said. So Garrett said it is 1 less than the term. So it would be the previous term. So we could definitely start with our base of 3 plus 2, because we're looking at the number of, we're adding 2 each time. But how many 2's is what we want to find out. So it is not the term that we are presently in, but 1 less. It's the previous term. So whatever term you're at, you're going to subtract 1 from that. And Gareth would have nicely said it. So here we come up with an expression, 3 plus 2 multiplied by n subtract 1, and that would have been n subtract 1 would have given us the previous term of any term. And we could definitely simplify this by opening our bracket here, and you would end up with 3 plus 2n subtract 2. And we could even further simplify this expression, and it would give us 2n plus 1. All right, so in order to determine what the number of tiles for any term, for the nth term, we could use this simple expression 2n plus 1, where n represents the term that we are looking at. All right? Now here we are looking at, we're plotting the information. What is the rate of change here? If we were to look at how each number of tiles is progressing. So we have 3, 5, 7, 9, 11. So here we are. So we have point A would have been plotted at 3, point B, which is the second term. So you can see the first term is 3, second term, that's B, is 5, third term. As you can see on your x-axis, you'd have the terms, and on your y-axis, you'd have the number of tiles. So C would represent term 3, D term 4, and E term 5. Is it the same as the common difference? If you were to look at the gradient as this line progresses, you'd see that the difference is the same. All right? So let's look. We have let's look at, I don't even want to touch anything, but let's see if I can get this pen in. So if we were to look at from here to here and look at the difference. So we know how to find the gradient. The gradient is rise over run. So you have 2 divided by 1, which would give us 2. And if I wanted to even go further, you would have, so you'd have 1, let me just put this in. All right, so you'd have 1, 2, 3, 4 here as your rise and 2 as your run. So that would be 4 divided by 2 still gives us 2. So the rate of change is 2. We're increasing by 2 each time we go up. Let's go there. All right. Let's hope that comes off my screen. All right, so the formula is the number of tiles equals 2 multiplied by the nth term plus 1. All right, here is another another pattern, and let's figure out what's happening here. How do we move from the figure at 1 to get the figure at 2? What is happening? Open your mics and share. Are there any hands up? How could we move from pattern 1 or the design at 1 to get to design at 2, and then of course tie in the third design? What is happening to the design?
Miss, so one block is added in every direction of the square. Like for term 1, you have a center square, and then there is 1 block on each side of the square. In center 2, you have 2 blocks on each side of the square. That's because with each term you add 1 to the side of the square.
Okay. All right. So if we add 1 to the sides, how many blocks are we adding in total?
4.
Okay, so for term 1, you can say you added 4 blocks, okay, to the main. Okay, so what you did for term 2?
You added 4.
Okay, and for term 3, you added 4 for term 2? You sure? What is your base? Let me ask the question. What is your base? You spoke about term 1 be, okay, your base is 5.
Yeah.
Okay, continue then.
Yeah, you added 4 blocks for term 2.
All right, so if if your base is 5, well, your term 1, then you have to call that entire, we're going to call it a cross for now. Or if you look at an open box, then. If you are looking at 5 as your base, you are now adding 1 to each of those 4 sides. But initially when you explained, I thought you were using that middle square as your base, and then you add 4 around that, and then you move to pattern 2. But okay, so for pattern 2, you'd start with your 5, and then you'd add 1, 2, 3, 4 around. Pattern 3, what are we adding?
4 around. I see
4.
what you're saying.
Okay. All right, so what do you think 4 would look like? How would you add 4? So pattern 1, we have 5 squares. Pattern 2, we have how many?
9 squares.
9. Pattern 3, how many we have?
13.
All right, so what is pattern 4?
We have 17 squares in total.
17. All right. So can you come up with a way in which we could figure out the nth term? So if you wanted to find the 10th term, 10th, how do we figure out the 10th term? Let's look a little bit more at the patterns that we presently have on the screen.
I
Go ahead.
multiply the term number by 4.
You multiply it by 4.
In all the terms, there is one center block, and then
Awesome.
is 4 other blocks based on which term. So 4 times 1, 4, 4 blocks around the block.
Okay. All right, so you're saying there's one center block which is constant, so that, and that's 1, and then you would add whatever term you're at multiplied by 4.
Yes.
All right, so we're going to call that term n multiplied by 4. So far we have 1 plus n times 4, and we can rewrite that as 1 plus 4n. All right, so let's try to see if it works with the third term, and then we try it for the nth term. With the third term. So the third term should be 1 plus 4 multiplied by 3, correct?
Yes, miss.
And that would be 4 threes is?
12.
12 plus 1 is?
13.
13. So and that stands to reason. All right, let's just run it by the second term to just make sure that we can move ahead. So the second term would be 1 plus 4 multiplied by 2. 4 times 2 is?
8.
8 plus 1 is?
9.
And we would have already decided that we would have had the first term being 5 tiles, the second term being 9, the third term being 13, fourth term 17, the fifth term is 21. All right, so we are definitely multiplying the term number by 4, and then we are adding 1 to it. So the number of tiles is equal to 4 multiplied by the term number with 1 added. Is everyone seeing that?
Yes, miss.
All right, great. So just to tie everything in, when you look at a pattern When you look at a pattern, whether it be dots or tiles or squares or triangles, you try to identify what is your base. Initially, if you remember, Garrett said it was 5, but he realized that if he used the middle tile as his base, he could now talk about the 4 being added to the 1. So it's 1 set of 4 that he would have for term 1. He would have 2 sets of 4 for term 2, 3 sets of 4 for term 3, and so on. So you identify visible patterns, and you use those visible patterns to help you predict what sequence, what term could come next. All right. So here we are, another sample question we would have done. Yes. Remember the sample question we did earlier on when we looked at the number of octagons and the number of diamonds that would have been a part of the pattern or a part of the sequence. Here we are, the number of dots, which is indicated by D, and the number of unit lines that form the perimeter of the shape P form a pattern. The values of D and P for the first 3 figures are written in the table below. Study the pattern and the number in each row of the table. Complete the rows numbered 1, 2, and 3. All right, so I'm going to go back to the pattern a little. Here we are, we spoke about the number of dots, and you can count them. You can see 1, 2, 3, 4, 5, 6, 7, 8 dots in the first figure, which is the octagon. For figure 2, how many dots would you see? So you should count it and see. And we can just move right to the table. So you see the number of dots here in figure 1 would be 8. The number of dots in figure 2 would have been 16 dots. All right. So if I were to go back to it and dot them just to make sure you're all where I am, you have, let's see. Hold on, guys. Okay, it's dotting. So we have 1, 2, 3. I don't want to leave anybody behind. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, great. So 16 dots because this one has 8, this has 8, but as you can see here, they're sharing 2 dots right here. But these 2 dots that they're sharing are placed back right here. One is here and one is here. So there's a little pattern there. I hope you're seeing it. So we have our 16 dots here. How many dots more should be added each time? Let us look at the table. Let us look at the table. So for figure 3, how many more dots is added? 24 subtract 16 gives us what?
8.
8. So we would have added 8 to 8 gives us what? 16, right?
Yes.
16 plus 8 gives us?
24.
Okay, so we can pretty much see a pattern there. So 24 plus 8 gives us what?
32.
32. Good. We're looking at the number of dots now. Figure 2 has how 3 sets of 8. And figure 4, what do you think would come here? Yeah, come on, guys. You should know this. It's now 4 sets of 8. So 4 sets of 8 will give us 32. Now they're also asking us to figure out the perimeter of the figure. Now the perimeter, let's go back to I have to go back here. Our perimeter is the lengths. Okay, so we had said that these are unit lengths. So we know that the octagon has 8 sides. So each side would call out 1 length. So the perimeter would be 8. All right. So here, let us look here to see what's the perimeter here. So we would have taken out, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter for the second shape is 14. So we can go back to our table. We can confirm it, right? So we can say that the number of dots is equal to D. D is the number of dots, which is 8 times n. So whatever the term is, we multiply. Hello?
Want to call me where it's finished?
Hello? We multiply the term by 8 to get the number of dots. All right, now what about the perimeter? Let's just look at the perimeter. So you have the first figure has 8 dots and the perimeter is 8. We could have said that it's the same. Once you have the number of dots, you could figure out the perimeter to be the same. But let us look at figure 2. Does that reasoning stands for figure 2? No, it doesn't, because the number of dots is 16 and the perimeter is 14. So we want to see what's happening there. But using figure 2 alone may not help us. So let us also look at figure 4. Figure 3, I should say. Figure 3 now has 20. What would have happened? What is the relation between 16 and 14? 24 and 20? 6. 6 for which one?
Underneath the 20. The relation for the perimeter figure is 6.
All right, so you have to help me a little bit more. Is it from 8 to 14 to 20 you're looking at?
Yes, miss.
Okay, so what you're saying, the difference from the perimeter from figure 1 to figure 2 is 6. And then from figure 2 to figure 3 is 6. There's a difference of 6.
Yes, miss.
All right, so that means you can determine what is the perimeter for figure 4.
Yes, miss.
What is the perimeter?
Miss 24.
24.
Not 24, miss 26. No.
Okay, it's 26. I agree with you. It is 26. Now, look what happened here. So if the table was organized in a chronological way, as in the next figure was a 5th figure and 6th, this would be easy because we just, add 6 every time, correct?
Yes, miss.
But I am sure that if you add 6 to 26, you don't get 86. Right? Hello? All right, so we have to figure out a way to determine for number 2, the figure number and the number of dots, and all that they have given us is 86. So let us establish some relationships here. Can we figure out how to get 26 from 32? Or 14 from 16? Can we use what is given to figure out can we find an expression that can relate the figure and the number of dots and the perimeter of the figure? I'm giving you just a little while to think about it and then we discuss.
Question again, because I'm having a hard time understanding. Please.
Hello?
Yes, I said I think I found a pattern to figure out the parameter.
All right. Tell me about it.
All right, miss. So the parameter of the figure is equal to 8n minus 8n minus 1 times 2, where n is the term number.
So it's 8n minus, go again.
Open bracket n minus 1 close bracket times 2.
All right. All right, how did you come up with that though?
Well, miss, the number of dots is already equal to the term number multiplied by 8.
Right.
And because when you're drawing a new octagon, you will always pick off the dots, and notice that for term 1, 0 times 2 is 0, so it's 8 minus 0, which is 8. For term 2, so 1 times 2 is 2 minus 14. And so notice that bigger number would subtract, the term number would subtract by 1 and multiplied to 2. You would always get the amount of dots that were paired between the octagons.
All right. Thank you so very much for your explanation. Is everyone following, or is anyone has a different way in which they would determine the relationship with all three bits of information given in the sequence? The figure number, the number of dots, and the perimeter of the figure. So Gareth just said, Gareth said P, which would be the perimeter, would equal 8n, which is actually D, subtract, open bracket, n minus 1. I hope you're all writing, because as you can see, you have to be writing to follow along. All right, and multiply by 2. He stated that he realized the relationship he looked at 1, and he realized that when he would look at the first term, subtract 1 would give him 1 subtract 1 would give him 0, and then 0 multiplied by 2 would give him 0. So he wanted to figure out he figured out that if he multiplied 0 by 2, he would get 0, and 0 subtracted from 8 would definitely give him 8. So he obviously plugged it in for the second term, which would be 8n, which is 8 multiplied by 2. Everyone is following? Subtract, the nth term is now 2, so it's 2 subtract 1 multiplying by 2. So let's work that out. So it's 8n, 8 multiplied by 2 gives us 16, and then 16 subtract 2 subtract 1 is 1, 1 times 2 is 2. So 2 subtracted from 16 gives us 14, and he would plug it in for the other terms. So let us plug it in for the fourth term, and then we're going to use it to answer the perimeter question with 86. So anyone else want to work that out for me apart from Gareth? Just walk us through what the perimeter would be, how they determine the perimeter for number 1. So it would be 8 times what?
8 times 1.
Remember, we're at not the first term. Maybe I mixed up the thing. We're at the fourth figure. So it would be 8 times what?
8 times 4, Miss.
Exactly. 8 times 4 is what?
32.
32. Good. What are we subtracting from the 32?
Which is subtracting, not 8, sorry.
So,
We're subtracting 26.
I didn't hear that. So it's 4 subtract 1 multiplied by 2. 4 subtract 1 is what?
3.
3 times 2 is?
6.
6. So we're subtracting 6 from the 32, which gives us what?
32, Miss.
26.
26. So you understand that it works for the one that we just figured out. And we figured out the 32 and the 26 by just looking at the numbers previously in the same column. And the reasoning was logical, right? Everybody remember that?
Yes, Miss.
And we had said that the number of dots is 8n. And we saw that if you have n being the figure number, so for the first figure, 8 multiplied by 1 gave us 8. The second figure, 8 multiplied by 2 gave us 16. The third figure, 8 multiplied by 3 gave us 24. And for the fourth figure, 8 multiplied by 4 gave us 32. So we agree that those answers are correct, right?
Yes, Miss.
All right, so we have an equation an expression working with, but let us simplify this expression. So we have everybody's writing 8n subtract open bracket n negative 2. Everybody's following?
Miss,
Could you
would you
just
like
repeat
Can
for us?
I repeat?
So okay, sure. We're starting from where Gareth had given us an equation that seems to be working. It stands that if we were to plug it in, we'd get all the answers that we now have on the board. So the equation that we started with is 8n. Let me see if I can put it up there. It's 8n subtract open bracket n subtract 1 close bracket multiplied by 2. So it's 8n subtract open bracket n subtract 1 close bracket 2. We have that?
Miss, can you please repeat, please?
8n subtract open bracket. Let's see if I can write it up here. 8. Oh, it's not writing so great, but at least you'll see it. Open bracket n. That n don't make it at all. Listen. This n, I couldn't just type it. Listen, people, this n is not coming. All right, I'm just going to write a capital now, sir. All right, this all right, let's try that again. No? Not allowing me to do anything else. So you should have 8n minus open bracket n minus 1 close bracket 2 on the outside. I want you to simplify that expression as best as possible. So as I said, we're going to use a 2 to multiply everything inside the bracket. So we are going to expand this bracket here. 2 multiplied by n gives us, so as you can see, it's negative. It's a negative 2 that's out there. So negative 2 multiplied by n. Okay, so before we multiply, let me rearrange because let me try this again. All right. I needed to go a little bit further. So we have n all right. I'm supposed to be able to do this. Doesn't look like I can put anything there.
Mrs. Lodge Fenton, please repeat
Yes,
what
dear.
it is. I'll just type it in the chat for you.
All right, thank you. 8n subtract open bracket n minus 1 close bracket 2. All right. So I was saying that we could easily clean this up by rearranging how we write it to make it be a little bit easier to understand. So let us put negative 2, so it's subtracting 2 multiplied by n minus 1. Everybody seen that now? And then we can definitely simplify. That's a lovely 8. We can definitely simplify the expression even more to let it be easier to use, because we have to go figure out what term and the number of dots. So we're going to have 8n. Now this negative 2 multiplied by 2 gives us what, guys? Yes, man, I know you know. Negative 2n. Right. And then you have negative 2 multiplied by negative 1 gives us what?
Positive 2.
All right. Plus 2. All right, great. Can this be simplified any further? Of course it can. So 6n subtract 2n gives us, no, 8n subtracts 2n gives us 6n, and we can have plus 2. So if you were to simplify the expression we started out with, we'd end up with this. And this can help us determine, and this of course is equal to what? What is this expression equal to? Is it D or P? Come on, guys, you have to be following. It is equal to P. It is equal to the perimeter. So with a simplified expression now, let us see. 1 times 6 is that. Let us try this expression for the perimeter for figure 1. So figure 1, n is now 1. Let us substitute. 6 times 1 gives us?
6.
6 plus 2 gives us?
8.
All right, let's try it for 2. So 6 times 2 gives us?
12.
12 plus 2 gives us?
14.
14. 14.
And they're asking you to find the number of dots and the figure number. So we basically need to find n in order to find d. because if we know what n is, we can easily work it out. But all we're given is p, the value for p. So what can we do to find out the n, the nth term? All that we have now on the table. All right, so we can definitely equate, we can equate 6. Why can't I write over this side, guys? I can't. So we can definitely equate the 6n plus 2 equal to 86 and transpose 4. So we're going to write 6n plus 2. All right, that don't look too good as a 2. I'm going to take all of this off the screen when I'm finished. Equal 86. So I want you to tell me.
Show me your company.
I want you to work out and tell me what is the nth term using that equation. So do that quickly.
The term is 14.
14. And there you go. Well, I clearly clicked too many things on the screen. So it is 14. Great. So if we have the 14th term, how do we figure out the number of dots again?
Repeat, miss.
How do we find the number of dots now that we have the figure number?
8 times
Right, so we just multiply the 8 times the n, so that would be 8 multiplied by 14 gives us what?
112.
112. Great. So that is for that. Now for the last, let's clean up this board. So for the last one, what is the nth term? If we were to write it in terms of n, and we would have definitely done that already. So we would have had 8n. Everyone agree that to find the number of dots, we'd multiply 8 by n?
Yes, miss.
And I did write it here as 8n subtract 2, open bracket n minus 1, but now we know that we can simplify that expression to be what?
6n plus 2.
Excellent. So whenever you have an expression, it works easier if you simplify the expression so that you can use it to find any term, or what we call your nth term. Is everyone there?
Miss.
Okay, you said yes, miss. All right, I think I need to click somewhere else on the page. All right, so let us, excuse me?
I don't know if it was long ago. Gareth's hand is raised. I don't know if it was long ago.
Oh, Gareth? I think Gareth just spoke, so I think it probably was not. Gareth, you're the one that just spoke?
Yes, miss, I just raised my hand.
Okay.
So while you were trying to simplify the formula 8n minus 2n minus 1, I was actually trying to solve the number of dots and the term, and I found a cool quirk that connects the perimeter of the figure and the number of dots.
Go ahead.
If you were to divide the perimeter of the figure by 2,
Mm-hmm.
then multiply the quotient of that by 4, and then subtract it by subtract it by n minus 1 times 4, then you would get the number of dots, and I just found that interesting. So.
All right, could you repeat that so that
All
I can
right.
write it down?
So you divide the number of sides.
Not the number of sides, it's the perimeter of the figure.
You divide the perimeter of the figure, so you're dividing p by 2. And then
multiply it by 4
multiply by 4.
to then subtract it.
So all that the answer to that, you subtract it.
You subtract it from n minus 4.
N minus 4.
No, n minus 1, like open bracket n minus 1 times
4. Okay. So n minus 1 open bracket times 4. So we're talking about 4n. So it's 4n minus 4 subtract. So we can simplify this and make it 2 subtract p times 2, which is 4n minus 4. That's 2p. All right. And this would be 4n.
So if we simplify that
plus
as
6.
Mrs. Fenton, Lord Fenton is saying, the half p times 4 would now become 2p. Garrett, you could type that in the chat then, and then we take it from there.
Also,
half p times 4 would give us 2p. So could you type that in the chat so we can see it?
What did you say,
And
miss?
then I'm saying type it in the chat. So the first part of the expression, p over 2 or half p times 4 could be simplified to 2p. So
Right.
you type that in the chat, that part in the chat, 2p, and then from that,
No.
the other part would
So
be
2p is the last part. So he's saying n minus 1 multiplied by 4 subtract 2p.
all right.
And n minus 4 multiplied by 4 can be not n minus 4, n minus 1 can be simplified to give us 4n minus 4 subtract 2p.
Yes. I also forgot to mention this, completely slipped my mind. So you're using the previous term number, not the current. So like
So
that's why you have the n minus 1. Okay, all right. Is that what n minus 1 would mean, Garrett?
Well,
n is the current term, so n minus 1 would be the term before that.
It says 2 times 4 because it would be 4 sides.
n minus 2.
Okay. Thanks for that, Garrett. I will check on it. It works, or how well it works.
All right, thank you, Garrett. All right. So here we are. Sorry, guys. So here we are, a real life application question with what we've been doing so far, sequencing and patterns. A theater has 20 rows. The first row has 18 seats, and each successive row has 2 more seats than the previous row. How many seats are in the last row? So I'm asking you now, we've been looking at various patterns, simpler ones and a little bit more complex ones. How would you help someone figure out how many seats is in the last row? And we're talking about the 20th row here. Derive a rule for the number of seats in the nth row.
Go up by 2 from 18. Go up by 2 from 18 for each row.
Right. So you would just write out from 1 to 20 and add 2 each time? No, go ahead. I can't hear you. I didn't hear you clearly.
No, miss.
What would you do?
For me, of the 18, put down 20. You know that
Okay.
2 times in a one way?
Right.
Yeah.
All right. So can you tell me how much is the 14th seat? The 14th row. How many seats is in the 14th row? So you'd have to write it down and add 2 all the way up to 14th, right? Right. So what I want you to do is look at what we've been doing and see if, so first we have, let us look what you just said. You said for row 1, we'd have 18, then you'd put 2 for row 2, you'd add 2 seats to row 2, right?
Yes, miss.
And you get 20. For row 3, you'd add 2 seats and another set of 2 seats, correct?
Yes, miss.
And you do that for row 4 as well. And row 5, you'd add the same 2, 2, 2 until you reach that. Great. But what if I don't want to sit down and write plus 2, plus 2, plus 2, plus 2, plus 2? Is there another way? Can you look at what we have written here on this in this table and figure out a rule similar to what we were doing?
Miss, I'm not sure
Miss,
about
I'm not
reading.
seeing the table.
You're not seeing the table?
No,
Mrs.
miss.
Darby? I don't know what to tell you.
You can take until the slide. I think you just need to move along. I'll tell you when I see. There you go. We're seeing now.
Okay. Okay, great. All right. So you see the table, guys? You have to answer. I know I can't hear.
Yes, miss.
Okay, great. So what rule you think we could come up with? How could you help me to avoid me sitting down and writing out 1, 2, 3, 4, 5, 6, 7, 8, 9 and adding 2, 2, 2, 2? How could you help me to find a simple algebraic expression to just plug in whatever row I want to figure out how many seats in?
Yes, I have a formula, but I don't know how would I
Tell me, man. Tell me, man. Tell me.
For example, say I want to know how many seats on the 7th row. You're going to write n is 7 times 2 plus
And it's 7 times 2?
n equals 7 times 2 plus 18.
7 times 2 plus 18. All right. Okay.
Is that for row 7?
Yes, miss.
All right. 7 times 2 plus 18. All right. So what if we wanted to find the 18th row?
Well, I just realized that there's an error with that formula. Plus 18 should be there. It should just be edge equals 18 or whatever number row you're trying to find times 2.
What do you say? You said 7. Wait, you said the seventh row would be 7 times 2 plus 18.
Yes, and I realized that there's an error with that because
Okay.
that's what I was saying. There's an error. And the error is that the plus should be there.
So what should be there?
What if you're trying to find the 18th row?
Mhm.
Then if you're trying to, then I realized that it's plus 18. You have to use the 18 empty.
You're a little bit far from the mic. I don't know what's happening. I hear you going in and out. I don't know if it's only for me or.
What I was saying, Miss, was
Thank
that.
you. Mm-hmm.
Miss, what I was saying was that for the formula, I originally said n equals 7 times 2 plus 18. And then someone asked, what if I'm trying to find the amount of seats in the 18th row? And then afterwards, I said I have to change the formula because now there's an error. Because using that formula, you're going to have plus 18 seats than what is actually necessary. So I just said that n would equal to the number of rows you want times 2.
No, you know, you're right in the first formula though. There was a little error there, but you have to add the 18 because the first row has 18 seats and every other row has 2 more than the row in front of it. So the first row starts with 18. So the second row is 18 plus 2. The third row is 18 plus 2 from the second row, and then 2 into the third row, 2 more into the third row. So you started out with something, but I want you to look at how the 2 is being added each time.
It is not being multiplied, I can say that. It is more of a number line jumping thing. I don't know what it's called.
All right, so tell me something before you rule out the multiply. When you have 2 plus 2, could we not represent that as a multiple?
We can, but only with those 2 figures because of just how the numbers work out.
So look at number 4. 2 plus 2 plus 2. What is that? Isn't that 2 times 3?
Yes, miss.
And then 2 times 2 would be what? 2 times 2. And then the 2 by itself could be 2 times what?
2 times 1.
All right. And then the first term would be 2 times what?
2 times 1, 2.
The first term 1, where you see the 18. How many sets of 2 you add in there?
0.
Oh, so it would be 2 times what?
0.
All right. So there's something there. You could always use 2. You could always add a factor of a multiple of 2, I should say. Or you could you could always look at 2 there.
So miss, would it be changed to, instead of saying let me use a 7th seat again for this. So I would say n equals to 18 plus 2 to the 7th power.
All right, so n, you are using n as what? Because we want to, let us put the number of seats.
As n, that's what I meant by n. N means the number of seats.
All right.
And
usually
instead of letting n with the number of seats,
yeah, let's
add a name already.
Right.
Can we call the number of seats S?
S?
S as in snake?
Yes.
Yes. So the number of seats, you can take it from there.
All right, so I would say that S equals to 18 plus 2 to the 7th power. You would use the whatever power you use would be for the corresponding row. So if you want to find for the 9th row, then you'd go to the 9th power. So you're just doing that for every other row that there is.
All right, hold on. Let's see. Let's not even go up to the 7. Let's see if it stands for this first, second, and third figure. I mean, number of seats for the first row. So for the first row, give me S equal what for the first row? 18 multiplied by n to what? 2 to what power?
Miss, it will be 0.
Is it to a power?
He said power, so I'd like him to see if it stands.
Don't all that, miss. It works for everything except for the first row.
Okay, it works for everything. So the second. Okay, so the second one would be to this first power, which would be 2. Second one would be to the second power, which is 4. Okay. All right, so it stands for everything except for the first.
Hold on.
Hold on.
Let's the fourth row. You say one of them would be 2 to the 7th. If you're doing the 7th one, what is the value of 2 to the 7th? When you do 2 to the 7th power, what answer do you get for that part of it? Of course, we'll have to add 18 to that. But what is 2 to the 7th?
Miss, you're supposed to get 14.
2 to the
14?
7th.
Hold on there. Miss, when you use power, it's not add.
No, dear. It's multiply. You multiply the number by itself 7 times. So it's going to be 2 times 7, 2 times 2 times 2 times 2, and you do it for 7 times.
2 to the 7th power is over. So 2 to the 7th power is way over 100, and that's not what you want.
Okay, miss, well, I see where I went wrong.
Okay.
You just need to adjust your power language. It's not so powerful. You're just looking at multiples this time, not powers.
Right.
2 times 7, not 2 to the 7th power.
And you already started out to say that 7 times 2, which is the same thing as what I think you were getting back at. So it's 18 plus, so your base is fine. You have to have the 18 in each of your, you have to have it for every row that you're going to look at, because that's your base. Okay? Now, let us look what's on the screen right now. For the second row of seats, you have 18 plus 2. The third row of seats, you have 18 plus 4. Then for the fourth row, you have 18 plus what?
6, miss.
So if how else could I write 26? 18 plus what gives me 26?
Miss 2, the 18 plus 2 plus 2 plus 2 plus 2 plus 2. You have.
No, you're gone too much. It should be 18 plus 8.
Yes, miss.
You see that?
Yes, miss.
All right. So what I want you to do now, to get the 18, I would have added what to get the 18?
Miss would have added. Okay, so which row are you talking about?
For the first row.
Miss, you would not add anything to get 18 because you already have 18. But 18 is the amount of rows that are there.
Okay, so it's 18 plus no, I still come. It's 18 plus 0, which would give us the 18, right? Because right. So how much would you add to get the 20? You already established that it's 2, right?
Yes, miss.
Okay. Can we
one set of 2? 18 plus 1 set of 2. Okay.
So we'd have added, right. So we'd have added no sets of 2 for the first row. All right, let us look at something else now. So if we were to rewrite what we've been doing in another way, let us look at the fourth row of seats, right? Are you seeing that?
Yes, miss.
The fourth row of seats, how many sets of 2 are we adding?
Hold on, where that negative one that come from?
Don't look at that yet. Tell me how many sets of 2 are we adding?
We're adding 1 set of 2, miss.
No, we're at the fourth row.
Oh, okay. We're adding 3 sets of 2s, miss.
Outside. One moment, please.
All right, let us look at it. So she was at the fourth row. And we say it's 18 plus 3 sets of 2s. How does the 3 set of 2s relate to the 4? We're recognizing that it is 1 less than 4 set of 2. So the rule seems to be 18 plus 4 sets of 2, but not quite. 4 sets of 2 less 1, which will be 3 sets of 2s, as we can see. Let us look at what happens in the third row. Mrs. Lodge Fenton, you're back. 18 plus, not 3 sets of 2 in the third row, but 1 less than 3 sets of 2. And in the second row, it's the same thing. A similar thing, I mean. It's 18 plus, not 2 sets of 2s. Where in the second row, it's not 2 sets of 2. It's 1 less 2 sets of 2. And then in the first row, 18 plus, not 1 set of 2, 1 less than 1 set of 2, which is 0 set of 2s. Mrs. Lodge Fenton, you're back. So then.
Oh, I'm sorry. I was here talking and I was muted. I do apologize. Yes, Mrs. Darby, I'm back. The young man.
Let's finish up with 5 and then
Sure.
Okay.
Sure.
So for 5, it would be 18 plus, not 5 sets of 2s, but can somebody tell me? 18 plus, not 5 sets, 1 less than 5 sets of 2s. You can continue.
Yes, 4 is correct. All right. So before I had to come off for a minute, the young man who asked me where did I get the 4 minus 1 from? Where are you?
Here I am, Miss.
All right, great. Let us look at the number, the row that we're looking at, and what we would have had with the rule. So as Mrs. Darby stated a while ago, in order to get the number of seats in the 5th row, we are adding not 5 sets of 5, as you said before. Remember when you said the 7th row would be 7 multiplied by 2?
Yes, Miss.
But you realized that it wasn't working out the way you thought it would, right?
Yes, Miss, because it ended up getting 2 more.
You're getting 2 more. Great. So if you look here, that's why I subtracted 1 here, because when I look at the pattern that I'm seeing, when I look at 18, then 20, then 22, then 24, then 26, when I look at it, if I'm at the 5th row, I started with 18. The difference between 26 and 18 is what? 8.
8, Miss.
How many sets of 2 can I get from 8?
4, Miss.
4. So I realize if I pay attention to the number of rows, but I subtract 1 from it, I can get the number of 2s that I should add to the 18. So I just wanted to make sure. So I look back at row 4. Row 4, I would have added 3 sets of 2s because I was doing that before. So 4 subtract 1 is 3. So it's 3 times 2, which is the 3 sets of 2s that I would have added to my 18. Are we seeing the pattern there?
Yes, Miss.
So if I was to look at my 10th row, how many sets of 2s would I be adding?
Miss 4.
Nine.
2, because I'm taking away 1 from the row all the time. So I'm taking away 1 from 2. Let me get my pencil here. My pen. From here, I'm at 2. And I'm not adding 2 sets of 2. I'm adding 1 less than the 2. So I'm adding 1 set of 2. I'm 1 here. And what is 1 less than 1?
0.
So I'm adding 0 sets of 2 there. I'm at 3 here. What is 1 less than 3?
2.
So you see that we're adding the 2 sets of 2s. So once we have identified a pattern that we're always adding 1 less than the row that you are in, we can now write it in an expression. So for the 4th row, I can say I'm adding 1 less than 4, which is?
3.
Good. So if I'm at the 10th row, what are you expected to see? 1 less than 10, right?
Yes, Miss. 9.
Right. So 9 times 2 is?
18.
18 plus 18 is?
30. 32.
36. 36. So what about the 20th row now? You have to tell me what about the 20th row?
Miss, you would have 1 less, we call it, I don't remember the word. 1 less than 20, which is 19.
Good.
Plus
Good.
18.
Right. We'd have 1 less than 20 plus, but 1 less than 20 sets of 2s. 1 less than 20 sets of 2s. Why 1 less? Because for the first row, we did not add a set of 2. We started to add a set of 2 in row 2. So if you really think about it, you'd have had 20 rows, but your first set of 2 was added at row 2. The second set of 2 was added at row 3, and you'd have gone up in that similar pattern. So it is 20 less than 1, which would give us 19 multiplied by 2, added to 18, which would give us, what is 19 multiplied by 2, by the way?
38.
38 plus 18.
56.
All right. So that would give us our 56 seats in row 20. All right. Now, we have all the groundwork here. What would be the algebraic expression to help anyone if the theater was supposed to expand and now have 40 rows of seat, and you want to help the architect to determine, to keep the shape that they have been working with, how many seats would they have in the next rows? What expression could we use to help the architect?
Miss, you would say that S equals to 18 plus what I can use R for row number of row.
You could.
So I would say that S equals to 18 plus open bracket R minus 1 close bracket, and then put 2 at the end, and that's the formula.
Excellent. Now simplify that formula for me, please.
What?
So I'm going to just write the formula you would have shared with us. All right. So you said S, which is the number, which is the seats, equal. So this is at any row now, 18 plus
open bracket R minus 1 close bracket, and then 2 equals, and whatever variable goes in, that's your answer.
All right then. So this would represent whatever row we're looking at.
Yes, miss.
All right, great. Can we simplify this expression that you have over here? Can you expand that bracket and simplify it for me? So it would be what? 18 plus 2R minus 2?
I'm thinking about that, miss.
So it's 18 minus 2 plus 2R. So that would be 16 plus 2R. So we could definitely keep it like that, or we could simplify it. All right, let us look here now. So we have, what's your name, sir? Buchanan?
Miss
Mark?
No, Michael Bradshaw, miss.
Oh, Bradshaw, Mr. Bradshaw. So you had used R in your expression, in your equation up there, but we can definitely use N. N is somewhat a universal letter that is used for the term number, right? But R would still be correct, because if you look at it, your expression is the same as mine. Agreed? The variable is the only thing that's different, the letter that represents the variable. So great job. And you could definitely plug in whatever row you are looking at. So the term is denoted by N, but you can work it with R and still come up with the correct response. So yes, we have 18 plus N. It can be rewritten as 18 plus 2 open bracket N subtract 1, and N would represent the term or the number, the row number that we are looking at. Awesome work. So as you can see right here, the number of 2's added is 1 less than the term number. So if you are at row 34, how many sets of seats are we adding? How many sets of 2 seats are we adding? We're at row 34.
Miss, you'd add 33 sets of seats.
Great. And we'd say 33 multiplied by 2 gives us 66. And we know that we've started with how many seats we started with?
18.
So we'd add 66 to 18, and it would give us how many seats we'd need to have in the 34th row. Correct?
Yes,
All
miss.
right. Great. Great job. All right. Let us look at this one, and then this will be our final question for the afternoon, and then we will tie up everything here. Wow. So we have examined the pattern here, and pretty much it's done for us, but let us walk through it. The pattern below, and then write an expression for the nth term. How many straws are in the first figure? So those are straws used to make a figure. How many straws we see in the first figure?
Miss, I'm not seeing anything. We're still on the last screen about the S plus 18.
What are you saying? See it now?
No, miss. No, it's short. Yes, miss.
You showing up now?
Yes, miss.
All right. How many straws do we see for figure 1?
No, that's the trapezium one. You've gone ahead of
Oh.
forward, one of the two.
All right. I'm wondering if I should just pop. All right. Let us. You seen it now?
We're still at the trapezium.
Anything?
Back to the number of seats.
All right. It will come back. Is it there now?
Same thing.
No, it's not. It's not there.
Click. Click.
You seen it now?
No, you're on the
No,
same
it's still
slide.
on the screen.
Really?
You want to go out and come back in?
That's what I'm wondering. I'm afraid to come out because it's going to start from the front.
You're there now.
Okay, great. All right, guys. So how many straws are you seeing in figure 1?
Miss, 35 straws. Sorry, 6 straws, miss.
Okay, great. So as you can see, the thing is already on the screen for you, but I just want you to be able to, when you are given this question in CSEC, I want you to look at the question and pay attention to the pattern that's being exhibited for you to observe. How many straws are you seeing in figure 2? Or better yet, since I have so much information on the slide, how did we end up with 11 straws?
Miss, every line that
Because
is the
there's
same
one
size
straw
represents-
joining both.
All right. So the 2 boxes, we're going to call them boxes, are shared. Because they're sharing a side. Okay? Figure 3, we see that it has 16 straws. So what keep on happening? How many straws are we adding?
5, miss. Miss, am I from?
5. We're constantly adding 5 straws.
Yes, we're constantly adding 5 straws. But can someone explain how we got to the n-1 in that end statement? 6 plus n-1 5 times. Can somebody explain why we got the n-1? It's similar to the previous question, but tell us. Is it because of what is happening in the first diagram? Are we adding plus 5 in the first diagram, in the first figure? Could that be it? Okay, 5n means number of straws, and then you take and you have 1 less. Okay, I'm seeing it. Yes, see that in the chat. Thanks, Gary. Continue, Mrs. Lodge Fenton.
We're talking about n being what?
But I said that after them, when they start to talk about n right there, I'm not really following what is going on right there.
All right, so n represents the number, the figure number or the term. So for instance, figure 1 would be 1. N would represent 1 there. So we have to learn to talk about each term within a sequence as a number. So the first term is 1 and the term is referred to as n. So let us look at figure 1. Figure 1 has how many straws?
Miss figure 1 has 5 straws.
Come again. Figure 1 has how many straws?
Oh, sorry. Figure 1 has 6 straws.
All right. So 6. What is the term that we're looking at? What term are we looking at in figure 1?
Miss, we're looking at the first term.
So the n would, so if I wanted to substitute the term that we're looking at for n, what would it be?
1.
Okay, so 1 subtract 1 is what?
0.
0 multiplied by 5 is what?
0.
0 plus 6 is what?
6.
All right, so what we're saying when we write an expression, it doesn't matter the term that we're looking at. When you substitute the term for the unknown, which is n, it gives you the number of straws or the number of seats. It gives you the number of things, the number value or the number pattern that you would have for any term. So n represents any term. So in this instance, I use n as our first term, hence why I put 1 here. And you realize that your answer was, whoops, that should be an equal sign. Your answer was 6, right. So if I were to use it for the third term, let's look at that. So we start off with...
Miss, I don't want to cut you, but...
Cut me.
6. All right, yes, 6 plus open bracket, 1 minus 1, close bracket, 5 equals 6, right?
Yes.
But I mean, what I was taught in math class in prep school is that you solve what is in the bracket first. That would automatically equal 0. So you're saying 6 plus 0.
No, you learn in math class that you solve what's in the bracket first and then you do multiplication before you do addition. So, because you have 0 in the bracket, you'd have to multiply first before you add.
Oh, okay. All right. Yeah, I see where I went wrong.
Okay, awesome. So, BOMDAS or PEMDAS or PEMMAS or any of those acronyms that you would have learned, it stands not only in primary school, but all the way up to forever. All right?
So, quick question is, what you're saying is that the 6 plus bracket 1 minus 1 times 5. But you're saying that the 1 minus 1 equals 0 and you multiply 5 by that 0, which will leave you with 6.
No. When you say 1 minus 1, what do you get from, what's the answer?
0.
0 times 5 is what?
0.
So 0 plus 6 is what?
Yes, that's what I just said. That's what I was asking. Is it that when you minus the 1, you have 0 and you multiply the 5 by that 0, that leaves you with the 6?
Yes.
Okay. Thank you.
You're welcome. All right. So what we're saying here, when you look at a pattern within a sequence, you have to understand where the base is. What is the first pattern? Hence why we have the what? Why we have the 6. The first pattern started off with how many straws?
Means the first pattern started out with 6 straws.
Right. So we represent our base. What do we do to get to the next figure? We have to start with our base because our base is still there. You see our base, right? You see the base right here. How many did we add for the first figure? We added 1 straw, 2, 3, 4, 5 straws. So we added 5 here. Okay?
Yes, miss.
How many sets of 5 did we add here? We added 5 here. Oops. Sorry about that, guys. Are you seeing the figure?
Yes, miss.
Yes, miss.
All right. So we added, where's my thing? We added 5 here for figure. What happened? It look like I can't go over there. All right. So we added 5 here and we added another 5 here. And you see it's represented right here, right?
Yes, miss.
Good. I don't know what's happened. So that being said, we can establish a pattern. You add 5 for the first figure, you add 5 plus another 5 for the second figure, and we could go on. We could say figure 4 will be what? 6 plus what?
6 plus 5.
Plus?
5.
How many sets of 5? How many sets of 3? So for figure 2, I added how many sets of 5?
1.
For figure 3, I added
one less.
Exactly. So when we realize the pattern, we can write it down in a simple algebraic way. So for figure 2, we've added 1 set of 5. We are at term 2, which n denotes the term. So it's 2 subtract 1, which is 1 set of 5 or 1 group of 5. For term 3, it is not 3 groups of 5, but 3 subtract 1. So it is 2 groups of 5. So if I'm at the 8th term, how many sets of 5 are you expecting me to add to the 6? I'm at the 8th. Good. So because I can't write down the number, when you're writing a generalized expression to help figure out what we call the nth term, we write
So for the generalized expression.
So you have your
Got you.
Mr.
Go ahead.
Audio,
You're back.
okay. So if we have the second term, it's n being 2. If it's at the 5th term, it's n substituted by 5. So whatever term you're at, you would substitute that value where you see n. And it would help you to determine the value that you're looking for, the number value that you're looking for, to help you figure out what pattern or how many parts, how many things, in this case we're talking about straws, should be used for that particular figure. All right. And of course, you can rearrange from here. We would have a rearrange 6 plus open bracket n minus 1 close bracket 5 to give us, so we'd have expanded. 5 times n gives us 5n. 5 times 1, negative 1 gives us negative 5. And then you can simplify. So it is 5n, still being a positive 5n. 6 subtract 5 gives us 1. So this here is the same as 5n subtract 1. Do we get that?
Is that,
So let me
is
get
that,
this straight,
is that
miss.
okay, or should it be bracketed?
Which one, miss?
Right there. Someone is asking how you got 5n plus 1, but there's no 5n plus 1. Isn't it, it would be 5n minus 5 rather than 5n minus 1, should it? I'm just asking. Oh, I see what, oh, is that an equal sign there? Got you.
No, it's a or.
Okay.
It should be 6.
It could have been an equal, you know. It's the same thing.
No,
I was
it
just,
should be 5n plus 1. Because you'd have.
oh yes, it is plus 1. It is plus 1. Guys, this really should be plus. Yes, it is plus 1. So this should definitely be a plus. My apologies. It should be plus 1. All right. Thank you so very much for pointing that out.
It would have been the 6, which is at the start.
Yes, so it would have been
and
6
the minus
subtract
5, which is at the end. which will give you a +1. 6 minus 5 is +1.
Yes.
Thanks for
All
that.
right.
Some chat was questioning.
All right. Awesome. Thank you so very much. All that have participated and turned out today to our CSEC discussion. Please look in the chat for an evaluation link.
Mrs. Lodge Fenton, could you let them take a picture of the next one and
Oh, sure.
take it away?
So please, when you're finished, you can definitely go and try this on your own to see how much you would have learned or remembered from the session. You can.
So they could take a picture of this and then you will fill in all the blanks and they take a picture of that and then work towards the answer. Take a picture without the answer. Take a picture with the answer and then you work it out by yourself and then you can discuss it with your teacher.
Or if you have your study groups, you could definitely discuss it in your study groups as well. All right, so I'm going to give you the responses now, and you can go and ensure that you check, that you work it out.
Miss, I have a question. What is the name of this topic?
Sequence and patterns.
Okay, thanks, Miss.
Right.
So Carol, let's place the evaluation link in the chat. You can look for it and let us know what you think of the session.
So there you can take the picture of the completed diagram, the completed table, and I hope you take the time out to figure out how we got to 16, 18 for the 4th term and 40, 42 for the 10th term, and of course, our expression for the nth term and the values that are also there for the 16th term. And although the figure is given to you, it would be a little bit cumbersome and time consuming to draw the figure out to give you all those triangles for the 10th term. Hence, the use of an algebraic expression does help to minimize the task of figuring out how the number of trapezia and the number of triangles that you would use. Please like, share, and subscribe to our Youth Region 1 YouTube math channel.
The name of the channel is what, Miss?
Region 1 Math.
Region 1 Math. Okay.
Okay, so it's Region 1 Maths team.
It would be on the flyer that you would have gotten the.
Someone can just type it in the chat for me, please, so that I can see it.
Okay, somebody did. But you can check the flyer.